What happens when the most powerful gravitational monsters in existence slam together? In a violent, catastrophic cosmic collision that shakes the very fabric of reality? Black holes are already the most extreme objects known to modern theoretical physics. They are regions of space where gravity is so intense that nothing can escape. Not even light, traveling at its cosmic speed limit, can find a way out. A single black hole violently bends space, dilates time, and swallows surrounding matter. It devours everything silently, leaving no trace behind in the dark void. But what occurs when two of these dark behemoths find themselves locked together? What happens when they enter each other's inescapable and violent gravitational grip? When two black holes collide, they produce the most energetic event since the Big Bang. In a fraction of a second, immense masses are converted directly into gravitational energy.
This incredible energy output briefly exceeds the light of all stars in the observable universe.
Yet, because black holes emit no light, this collision occurs in absolute optical darkness. It sends violent, invisible ripples through the fabric of space and time. These powerful gravitational waves travel across billions of light years through the cosmos. How do two black holes draw close enough to initiate this final orbital dance? What happens to space, time, and gravity when their event horizons finally touch? As we approach the event horizon, the equations of gravity reveal themselves, tracing the path of space-time itself in this mesmerizing display.
The collision of two black holes is not a sudden, instantaneous cosmic accident.
It is a highly complex process spanning millions, sometimes billions, of years.
It begins with the Inspiral phase, where two bound black holes orbit each other.
Initially, they are separated by millions of miles, performing calm, wide orbits.
According to General Relativity, accelerated massive bodies continuously radiate gravitational energy.
As the binary pair orbits, they constantly bleed energy into the cosmic fabric. This energy is lost in the form of faint ripples in space-time. Losing this orbital energy forces the two black holes closer with every revolution. As the distance between them shrinks, their orbital speed begins to accelerate dramatically. Over eons of time, their slow, cosmic dance transforms into a hyper-fast spiral. In their final moments, they revolve around each other hundreds of times per second. Their orbital velocities reach significant and terrifying fractions of the speed of light. The extreme gravitational forces near their event horizons warp all surrounding starlight. This warping effect distorts background stars into hypnotically beautiful double Einstein rings. Space-time surrounding the pair is stretched and twisted into a violent gravitational maelstrom. The cosmic stage is now set for the inevitable, catastrophic final union. Gravity becomes so intense that the surrounding coordinate grids of space completely break down. They draw closer, spinning faster, dragging the universe itself along with them. The second major stage of this cosmic collision is known as the merger.
This is the precise, fleeting millisecond when the two event horizons physically touch. As the two outer boundaries meet, they fuse into a single, highly distorted shape. They briefly form a strange, peanut-shaped black hole, oscillating violently in space. During this split-second touch, classical laws of physics reach their absolute limits.
The extreme orbital velocity converts several solar masses of matter instantly into radiation. To put this in perspective, the equivalent of 3 entire suns transforms into pure energy in milliseconds.
This mass is converted entirely into pure, raw, disruptive space-time energy.
If this event released visible light instead of gravitational waves, it would be blinding.
It would easily outshine the entire night sky and every galaxy we can see. Yet to human eyes, it remains an invisible, silent phantom in the dark. Space and time around the merging boundaries fluctuate wildly, destroying standard geometry. Time dilation reaches near infinite levels at the exact point of the collision. Light paths are frozen in place, unable to escape the growing gravity well. The sheer energy release shakes the cosmos, sending shockwaves across the universe. Any matter or gas clouds near the collision zone are violently thrown outward. This sudden mass loss acts like a cosmic leaf blower on surrounding space. It is a moment of pure, raw gravitational power, unmatched by anything else. Following the chaotic merger comes the third and final stage, the ringdown phase. Immediately after fusing, the newly formed black hole is far from a sphere. It is a lumpy, violently vibrating mass of pure, severely distorted space. Like a struck bronze bell, the newly formed cosmic center resonates out into the void.
It vibrates intensely, emitting rapidly decaying gravitational waves into the surrounding cosmic ocean. As these final quakes shed excess energy, the black hole rapidly smooths out. Within mere milliseconds, the vibrations subside, leaving behind a stable cosmic giant. What remains is a larger, perfectly smooth, rapidly rotating Kerr black hole. But the collision leaves behind one final, dramatic, and unexpected physical consequence. This phenomenon is known to astrophysicists as the gravitational recoil kick. If the merging holes had unequal masses, gravitational waves are emitted unevenly. This asymmetric wave blast acts exactly like a giant cosmic rocket engine. It violently kicks the newly formed black hole in one specific direction. The newborn black hole can be slingshotted away at millions of miles hourly. In extreme cases, this kick is powerful enough to eject it from its galaxy. The newly formed giant is cast out. It travels through intergalactic space as a rogue, completely solitary cosmic traveler. A silent predator, drifting forever in the cold expanse between the stars. For centuries, humanity had absolutely no way to detect these invisible collisions. Because black hole mergers produce no light, traditional optical telescopes remained blind. That changed in 2015,
when advanced laser interferometry observatories made history. Scientists constructed massive, miles-long, L-shaped subterranean vacuum tunnels on Earth. These detectors are capable of measuring spatial shifts smaller than a single proton. When gravitational waves pass through Earth, they subtly stretch and compress space. By converting these space vibrations into audio frequencies, we can finally listen. A black hole merger sounds like a rising cosmic chirp to our instruments. It increases rapidly in pitch and volume, right up to the collision. This breakthrough opened an entirely new window into modern observational astronomy. We are no longer just looking at the universe. We are hearing it. The collision of two black holes is a masterclass in cosmic relativity. From the long Inspiral spiral to the invisible merger and final recoil kick. Each detected merger provides crucial tests for our theories of quantum gravity. As space-based observatories launch, we will detect collisions across far greater distances. The universe is filled with quiet, invisible symphonies, just waiting to be heard. Which phase of a black hole collision did you find the most fascinating? Subscribe and hit the bell to keep exploring the deep wonders of our cosmos.